All right, good evening, everyone, and welcome to the Sauk County Well Water Monitoring Program update. I'm so glad all of you can join us tonight. My name is Jenny Erickson. I work with Extension in Sauk County. If you're not familiar with Extension, it's kind of like what it sounds. It's an extension of UW-Madison, and our job is to connect research and resources of the university to all corners of the state. In my case, that is Sauk County. And I'm just going to do a brief intro, get everyone acclimated, and then I'm going to hand it over to our presenter tonight, Kevin Masarik. So first off, I want to thank everyone for participating. We had over 400 Sauk County households that agreed to participate in our well water monitoring program. So that was an amazing response, and so I really appreciate that. So thank you all for doing this. And tonight, we'll be talking about kind of an overview of that groundwater monitoring or well water monitoring program. We'll give a little bit of overview on that, share some of the initial findings from year one of a 5-year program. We're gonna help with any issues around interpreting your results, and then we're gonna answer some questions. The other thing I want to mention is that this program is a joint effort. We have Kevin Masarik on tonight from the Center for Watershed Science and Education, and from the University of Wisconsin-Stevens Point. This is also a joint effort from multiple departments within Sauk County. So I know we have folks on tonight from Land Resources and Environment. Public Health is involved, as is Extension in Sauk County. I also want to mention that this program was initially funded through the Ho-Chunk Nation, and we want to have a big thank you to them as well. So I wanted to point out, I have this weird window that keeps popping in my screen here, so I don't know if you can see that or not, but all of the information tonight is being recorded and will be posted on our Sauk County Extension website. Also, the PowerPoint for this I'll put that, the Kevin shares, I'll put that up there tomorrow as well. So if you want more information about any of this, the website to go to is sauk.extension.wisc.edu. So for all future information, for this recording, for the PowerPoint, anything like that, you can always find it there. Otherwise, you can call our office at 608-355-3250. Couple of Zoom basics. Everyone is muted at this point, in part because I'm just trying to keep any distractions down, except for the presenters. I'm going to unmute all of you when we have some time for questions and answers, so you'll definitely get an opportunity to ask any questions. And as I mentioned already, the presentation is being recorded. If you have questions during the presentation, you can always put them in the chat box, and I'll be watching those, and then we get to questions and answers, we can start with some of those questions as well. So just know those are some options, and we will have time for questions and answers. With that, I want to introduce Kevin Masarik. Kevin, I've been working with Kevin for at least, I don't even know, 15, 16 years. He has spent a lot of time in Sauk County working on groundwater and well water issues. He is a groundwater extension specialist at UW-Stevens Point and with Extension. I put his contact information up here. I refer to him as the guru of groundwater. He knows all, I'm sure of it. So he's going to walk us through the initial findings and share with you information and help you interpret your results. And so with that, I'm going to stop sharing and I'm going to hand it over to Kevin to take it from here.
Thanks, Jenny. And thank you everybody for joining us tonight. This is a great turnout for a virtual event. We know this isn't ideally how we plan to roll out the information. We were hoping to do an in-person meeting. Obviously, that's not possible these days with this large of a group. So we're grateful that you're braving the technology and joining us for tonight's presentation. What I hope to cover, Jenny mentioned that our center worked with Sauk County to conduct this project, and it really was initiated at the county level to try and answer some questions about groundwater, but the main one being, the main question I get a lot about groundwater from communities is our groundwater getting better or worse? And quite frankly, most communities aren't set up to answer that question very effectively. Sauk County has been really good at offering voluntary testing it has a really good baseline understanding for groundwater quality in Sauk County, but it's pretty limited in its ability to understand how widely does groundwater or well water fluctuate from year to year. Is groundwater quality getting better or worse? And if so, what are the contributing factors to that? So that's a little bit of background for how this project came about. Is they were looking for a way to try and answer some of those questions. What I'd like to do in talking about the information is provide just the basics of groundwater in Sauk County, in case anybody has questions about where their well water comes from. But I think it's also important because it sets people up to understand maybe how we recruited participants and what we're hoping to learn from the process. Also, as Jenny mentioned, we'll be talking about what individual test results mean. I'd imagine that's a lot of you on the presentation today maybe have some questions about those results that you should have received in the mail from the sample you submitted. And then we'll talk briefly about what we've learned so far, and then looking forward, what we hope to learn and what comes next in terms of your participation. So just transitioning into groundwater basics a little bit. Our groundwater in Wisconsin is not an underground lake. It's not an underground river. It's just rain or snowmelt that soaks down into the ground and eventually reaches a point where all the empty spaces in the cracks between the rocks, where all the empty spaces between soil are filled with water. And that's our groundwater. It's not an underground lake. It's not an underground river. It's just the water moving through the empty spaces in the soil and rock below our feet. And again, it originates basically as local rain or snowmelt. We use wells to access water and bring it into our homes. We're fortunate that you could install a well almost anywhere in the state of Wisconsin and get ample water for your household needs. We can also use those wells as access points or windows to sample groundwater, well water quality, and that really helps us paint the picture of water quality in Sauk County and also at the state level in some respects. The other thing to point out about this slide is that you'll see the arrows. Groundwater is always moving very slowly, and it typically moves from those areas upper in elevation or higher in elevation to areas lower in elevation, where we find lakes, rivers, streams, and wetlands. So the water table elevation helps us understand groundwater flow, but the eventual destination for all of our groundwater will eventually be some sort of surface water feature, and it's usually a local surface water feature that water is flowing to. So if you think about your individual well at home, I always tell people a good rule of thumb is that the average household well is probably accessing water that recharge within maybe a quarter or a mile of the well itself. And if you know a little bit about the groundwater flow direction, that maybe gives you some indication of the land use or the rocks and soils that help dictate your individual well water quality. This just illustrates what we know about water or groundwater flow in Sauk County. Basically what you see on the right, and I don't expect you to be able to interpret it very well, but I show it just to highlight the fact that this information exists. And if you want to get a better understanding for the direction of groundwater flow, specifically maybe where you live, these maps are available. And what it is it's a map of elevation of the water table. Just like the land surface has changes in elevation, if we look just at the top of the water table, like that diagram on the lower left, what we'd see is that the water table also has changes in elevation that we can use to make predictions about how groundwater moves. And what I'd like you to notice is just how short some of those arrows are, highlighting the fact that most groundwater is not traveling hundreds or thousands of miles. In fact, most of it's probably only going a mile or maybe less before it reaches a nearby lake, river, stream, or wetland. And when we talk about water quality, which is the reason this study was brought about, it's important to point out that water is the universal solvent, and it naturally has the ability to dissolve stuff that it comes in contact with. So as much as we all want pure water, we never find pure water in the environment, and certainly not in people's wells. All well water is going to have impurities that depend on the rocks and minerals that water travels through, the types of land use where that water recharges, even the types of plumbing and packaging that water is stored or transported in can impart different impurities. There are certain impurities that we know are not good for health. And when those impurities reach certain levels, then we're worried about them as environmental or health-related contaminants. So one test in particular that we offered in this program, the nitrate test, is one that does have some health considerations associated with it. And we'll want to be able to communicate with everybody what those safe levels are and what else we can learn about the water from the various tests. If there are any indications of problems with people's water, also important to point out that we know a lot about treatment methods or other opportunities to provide or direct people to methods that would allow them to access safe water. So transitioning into the groundwater again, you may have heard the term aquifer, and that's just the fancy name we give to the geologic storage units that hold or store our groundwater. And I have the map of Wisconsin on the lower right. It's kind of a three-dimensional map of the state showing this layered cake geology of the state, where the lowermost layer is what we call crystalline bedrock, and that's a layer that doesn't hold or store a lot of water because it behaves much like somebody's granite countertop at home. Wisconsin's groundwater sits in those geologic layers above the crystalline bedrock. In parts of Sauk County, that's going to be alternating layers of sandstone and dolomite. And in other parts of the county, it might be sand and gravel deposits that were left behind by the glaciers. But understanding geology is really important for determining things like how quickly groundwater moves or how easily groundwater becomes contaminated. So the pictures of the geologic materials in the upper right here show different structural characteristics of certain geology. And if we think of water moving through large cracks or fractures in rock, that water is not going to have an ability to be as filtered as well as, let's say, water moving through tiny spaces in between sandstone or maybe sand particles. So as groundwater scientists, we study geology a lot because it's really critical for understanding groundwater movement, but also some of the water quality aesthetic related issues that people might be dealing with. This is a map specifically of Sauk County, just showing how variable Sauk County geology is. So the areas in orange, the darker orange, are areas where we have what we call carbonate rock. Those are usually dolomite type rocks that tend to be highly cracked or fractured, where water might be stored or moved through. It's also a rock that contains calcium and magnesium, which can impart different or certain aesthetic qualities to the water. There's other areas in the light orange that would indicate that the uppermost bedrock layer in those regions is going to be sandstone. So think of sand particles that are cemented together, but still have empty space that allow the water to move through it. And then those areas in yellow, most of you might be familiar with that area. That would indicate the Baraboo Hills region. And the Baraboo Hills would be areas where there are exposed areas of crystalline bedrock near the surface. And those are areas where, quite frankly, it's really challenging for wells to access water. And you'll see from a lot of the maps that we're going to show that there's not a lot of samples from those areas. And part of it is because there's state forest lands or state parks, but also because it's quite challenging for a household to get good water or ample water in those regions as well. Depth to bedrock can be important for understanding groundwater as well, and you'll see that in a lot of the areas of Sauk County, the depth to bedrock, particularly in the driftless region on top of the hills, there's a lot of areas where it might be less than 5 feet to rock. with that little soil, that offers a lot less filtering ability than areas, let's say, along the Wisconsin River Valley, where you might have greater than 100 feet of sand and gravel deposits for the groundwater to move and be stored and be filtered with. So depth to bedrock, or the depth of the surficial deposits, is also something that we take into consideration. And then we have the type of surficial deposits, which is also important. So the areas in orange would indicate sand and gravel kind of soils. The areas in green would be more loamy, or even maybe some clay soils if you're near the Baraboo River. The soil is obviously the first kind of line of defense for our groundwater. It's like the skin on our bodies. So the soil texture and the soil properties are also important for determining how easily water might be contaminated in somebody's well. And then the last map I'm going to show here quickly is the land use map, just showing how variable and diverse Sauk County land use is. There's different types of agricultural crops that are grown. Certain areas might be more intensively farmed than others. The areas in the light green would indicate forest or more natural settings. And the areas in gray would indicate more urbanized environments. The point of this map and the previous maps is just giving people a sense of how complicated the soils and geology and land use of Sauk County are. And that's really a critical component of this study, was trying to characterize all those factors for folks. The last complicating factor to designing this project is knowing that well depth and well casing also play a role in determining water quality. So in this diagram, this might indicate a well maybe in the bluffs, a limestone bluff in Sauk County, where the depth of the well is illustrated here, and then the black line extends just to the top of the water table. And that black line would indicate maybe the casing depth. And in the case where the casing extends just to the top of the water table, we would know that basically the rest of that borehole or the rest of that well would be exposed or open to the aquifer. So in this situation, the casing, really only extends to the top of the water table and allows, very shallow or relatively young water into that well water system quite quickly. If we were to deepen that casing further into the aquifer, we're sealing off a large section of groundwater and pulling water from much deeper. That water is typically going to be older. It might be coming from further away, which gives it an opportunity to be maybe a little bit more diluted or filtered by the geologic material. So well depth as well as well casing are also critical components for understanding why somebody's well water quality might be the way it is. That information really is designed to help better communicate the intent or our recruitment strategy. I'm sure a lot of people are wondering, why was I selected? Why was I selected and maybe not my neighbors? And we were very intentional about who we contacted with. We intended on soliciting people with wells mostly drilled after 1988, and that year is it was chosen because that was the date when the Wisconsin DNR started to require Wisconsin unique well numbers, which allows us to relate an individual well with an individual parcel. It also provides access to information on things like well depth, casing depth, depth to water, as well as geology, which we highlighted how important that information is in understanding water quality. So that was our first criteria, was looking for wells with the Wisconsin unique well number. And then we attempted to locate one well per section that met that criteria. And in some areas that are more densely populated, we might have had multiple choices. We might have had 5 or maybe 6 or even more people that met that criteria. But we attempted to locate one well per section, and that wasn't always possible in all locations, but it allowed us to get a good spatial distribution of wells across the county that would account for a wide variety of soils, geology, and land use. And then all things being equal, we gave preference to any landowner that participated in previous extension well testing efforts, because we felt there was a high likelihood that if they've worked with us in the past, that they'd likely work with us again. And it also meant we had access to previous water quality information, which could also be valuable to reconstruct some of this information. So that was our recruitment strategy. How successful were we? A total of 802 landowners were sent recruitment materials. And as Jenny stated prior, that there were over 400 landowners that indicated their interest in participating. We expected about a 35% participation rate, and we vastly exceeded that, which I should never be surprised in Sauk County that people would be motivated to participate in these types of programs, because they always have a tremendous response, and that was certainly the case with this program as well. When all was said and done, we received 394 actual water samples to the lab that were analyzed. And really the goal of this whole project is to try to better understand water quality changes over time. And I tell people that we're trying to create basically the Dow Jones Index for Sauk County groundwater or well water. We want to be able to provide information to residents as well as local officials on, is well water quality generally getting better, worse, or in a lot of cases it's probably staying the same. But even that information will be useful for understanding things like how widely, or what's typical for nitrate levels to fluctuate. Or maybe we'll be able to learn something about how does weather variability impact water quality. If we have a year of really high rainfall, do we see noticeable response in the results compared to other years? Those are all things that I think are only possible by conducting a project like this, where we're asking people to submit samples from the same wells for multiple years in a row. So we know this project works best when the wells are representative of diverse geology and land use, which we feel we have. And it also works well if the same wells are sampled every year. So this is my one pitch to everybody listening. We really want you to participate in years 2 through 5, and we hope we've made it easy enough for people to continue to do that. And we will work hard to be able to do that, because it really is important for the project. So the overview of where we've been this year so far is you were contacted and recruited sometime late last year. In January, we mailed out sample kits. Participants collected samples and mailed them back to the lab between February and sometime in March. March and April, we were analyzing samples, and then we mailed out results. I believe it was late April, maybe early May, which brings us to the presentation here. This is the first time anybody has had an opportunity to hear about the information other than the individual results that you may have received. That's intentional. We want the participants to be able to be the first to see the results and learn from that information before that information is made publicly available. The other thing we'll cover briefly is what tests we performed, and you might have some question about why we performed those tests. And just highlighting the 6 tests we offered were nitrate and chloride. Nitrate and chloride are useful for understanding land use impacts. Total hardness, alkalinity, and pH give us some ability to understand how rocks and soils impact groundwater. And then conductivity kind of combines those two. It's an overall water quality test, which allows us to kind of understand the combination of both land use, rocks, and soils. And that one will be useful, again, as we move forward. If there's a lot of weather variability, it will be interesting for people like me to understand, does the conductivity or do these other tests vary from year to year based on weather? The nitrate and chloride in particular we're interested in because we want to know, how does land use impact groundwater? And if wells are getting better or worse, what can we learn about those particular wells that can be interpreted to other parts of the county or replicated say, groundwater quality is getting better. So getting into the actual tests, very briefly, I'll cover each test. The first one being total hardness. Total hardness is simply the measure of calcium and magnesium in water. It's naturally occurring, but it does cause some aesthetic problems. There's no health concerns associated with hardness, but it does cause problems like scaling, soap scum. People with hard water tend to use more detergent. And over time, hard water may decrease water heater efficiency. Generally speaking, anything greater than 200 would be considered to be hard water. 150 to 200 is kind of an ideal range, and then anything less than 150 would be considered soft and might be a little bit more aggressive or corrosive. So those people with water hardness greater than 200 may choose to install some sort of water softener. And water softeners are kind of tried and true technology for reducing the negative impacts that come along with calcium and magnesium. It removes those elements, but does exchange it oftentimes for sodium or maybe potassium if you're using potassium chloride salt. So considerations with softening, we're not generally too concerned about how much chloride might be discharged to soil or to groundwater, but in some cases, discharge of chloride might increase chloride levels slightly. Also, the softening process, because it increases sodium, some people that are on strict low sodium diets might want to avoid using softened water for drinking water purposes. So anybody that is softening, a lot of times folks will bypass their primary drinking water faucet. Many times people will avoid softening water for outdoor use because it will, one, save on salt, but also it's largely unnecessary because most plants don't care if there's calcium and magnesium in the water or not. And then if you are someone that is replacing the water softener, we generally encourage people to look for one that regenerates based on volume rather than a set time period, because it could be one way to save on salt and reduce the amount of salt that might end up in groundwater. Some of the other tests that we performed, alkalinity is the ability to neutralize acid. Again, that's naturally occurring. There are no health effects associated with alkalinity. But again, it helps us determine how corrosive water is likely to be. And there are parts of Sauk County where the low levels of alkalinity, the low levels of hardness, as well as the low pH levels will make water more corrosive. And there's some maps of the results that will help highlight where those areas exist. pH was another test that we performed, and most people are familiar with pH. You know that things that are acidic are corrosive, and things that are acidic would tend to be less than 7. Things that are basic would have a greater tendency to form scale. And there is what we would consider to be kind of a wide range of pHs in Sauk County. Again, that's mostly due to the diverse geology that exists in the county. If we look at the maps of those results, and these I know are probably pretty small, but we are developing an online tool that would allow people a little bit greater ability to interact with this data. I think what I'd like to point out on these 3 maps are that alkalinity, total hardness, as well as pH kind of mimic one another in some ways, in that the areas around the Baraboo Hills, as well as the northern towns in general, tend to have softer or water with lower hardness, and they tend to have water with lower alkalinity. And that's going to make water in those areas a little bit more corrosive or aggressive. So people with copper plumbing or maybe metal plumbing might have more issues with, let's say, corrosion or pinhole leaks developing over time. Those areas in the central portion, especially the kind of the southwestern portion of Sauk County, are typically going to have a little bit harder water, as well as those far eastern towns of Sauk County are also going to have fairly hard water, where water hardness and scaling is typically going to be more problematic. If we look at what controls total hardness and alkalinity and pH, again, we're looking at the geology. So this map is just kind of highlighting, Again, the Baraboo Hills region, which correlates really well with some of those areas of low pH, low hardness, low alkalinity. And then there's areas up in that northern part where the sandstone is really void of a lot of carbonate minerals. It means that water tends to be a lot more corrosive in those areas, especially kind of the areas around the dells, Lake Redstone, and some of the other areas around there. It wouldn't be unusual to have fairly aggressive or corrosive water. The next test I'll highlight is the chloride test. And chloride would be something that we performed because it gives an indication of land use impacts. Naturally, we would expect the chloride levels to typically be less than 10 milligrams per liter. So when it gets greater than 10, that's providing some indication that land use is impacting water quality to some degree. When chloride levels get above 250 milligrams per liter, there aren't any health effects associated with that chloride, but it can give water kind of a salty taste, as well as speed up corrosion of certain metals like stainless steel. So 250 is kind of an aesthetic standard or aesthetic threshold that can be important for some people to determine whether additional action is necessary. When we talk about where chloride comes from, fertilizers, mainly potash fertilizers, a lot of times is going to be potassium chloride. And while the plants need the potassium, the chloride tends to leach into groundwater quite easily. So some of the elevated chloride that we see in Sauk County might be coming from fertilizer activity. Septic systems would also release some chloride. Human waste would contain chloride. And areas where people have water softeners, or where water softening is going to be more likely, those septic system drain fields would be discharging a little bit more chloride. And in some cases, that might be one reason why there's elevated chloride levels. The other reason would be road salt activities. So road salting is great for de-icing our roads in winter, but that water melts in the culverts. In springtime, a lot of that water is going to recharge into groundwater, and that water is going to contain, a lot of times, fairly elevated levels of chloride. So when we look at the results from Sauk County for the basically 394 water samples that we received, you'll see this map right here illustrating the chloride levels, where the light colored dots are low levels and the darker colored concentrations are typically the higher concentrations. And these maps would never allow anybody to see water quality at an individual parcel level, but it does help illustrate the variability of well water throughout the county. And what you'll see is that the darker areas oftentimes occur near more of the urban centers of Sauk County, where maybe the darker dots or darker wells would be located along major roadways or highways. And that provides, probably pretty good indication that the closer you are to an urban area, maybe the higher the probability that you might have a little bit of elevated chloride in your well, or maybe that's the source of the elevated chloride in somebody's water sample. In looking at the summary, there was only 2% of wells that tested greater than 100. I think good news is that 58% of all the wells tested in this program were less than 10, so at that background or that natural level. The average was about 16.6, and the maximum concentration was 545. If we look at the next test, the nitrate test, this is probably the most important test that we performed on your water samples. And it's important, one, because it provides an indication of land use impacts, but two, it also gives us an indication of the safety of the water supply. So nitrate is something that has a health standard. We know the safe drinking water level is 10 milligrams per liter. So anything below 10 is considered suitable for drinking. Anything above 10 is considered unsafe for infants and women who are pregnant or who may become pregnant. And we really do encourage everyone to avoid long-term consumption when nitrate levels are above 10. The other thing that we can learn about nitrate from this test is that natural or background levels in groundwater are typically less than 2 milligrams per liter. So any results that are above 2 provide some indication that the land use is impacting water quality in that region or that particular well. When we look at the health effects with nitrate, for infants, the concerns are mainly methemoglobinemia. Some people refer to it as blue baby disease. It's a condition that can be fatal in infants less than 6 months of age. For women who are pregnant or who may become pregnant, there's possible links of nitrate to birth defects as well as miscarriages. That's true for humans, but also livestock as well. So this might be a concern if you have livestock that you're trying to raise on your property. And then for the rest of the population, there's increasing investigations and research into the impacts of nitrate on thyroid disease, as well as risks of certain types of cancers. So for those reasons, we really want everyone to avoid concentrations of nitrate above 10 in their drinking water. And certainly we never want infants or women who are pregnant drinking water with greater than 10 milligrams per liter of nitrate-nitrogen for those reasons that we just discussed. When we talk about the sources of nitrate, again, agricultural fertilizers, all nitrogen fertilizers, it would be great if all of that made its way into the plant, but some of that nitrogen will escape into the groundwater as nitrate. Animal wastes or biosolids that are stored or spread on the land surface, we know will also be converted. Some of that will be converted into nitrate, which escapes into groundwater in certain areas. Septic system drain fields, human waste, similar to animal waste, will decompose and release nitrate. So that can be problematic, particularly in areas where you might have small lot sizes where everyone's on a private well, as well as a septic system. And then certainly lawn fertilizers will contain nitrogen, and that can be problematic as well in certain areas. So those are really the main sources of nitrate. And if we look at the Sauk County results, here we would see a map of nitrate concentrations with the blue, the dark, and the light blue dots indicating natural or background levels. There's the light yellow, the orange, and then any of the red dots would be wells that actually exceeded that 10 milligram per liter standard. And that was about 9% of all the wells tested through this program were considered above or greater than what's acceptable for drinking water. That's very comparable to the statewide average. The statewide average is basically 9%. So although that might be alarming to some folks, that is pretty in line with what we see statewide. There's certain areas where it's better, and obviously there's areas where it's worse. But I'd say Sauk County is about average when it comes to nitrate concentrations in groundwater. What you'll see is it's not necessarily distributed equally across the county, however. So one thing we're going to try to find out is, over time, how are those nitrate levels changing, if at all? And if certain wells are changing, what can we learn about the land use around them that maybe either contribute to its increase or hopefully contribute to its decrease that we can replicate in other areas and actually improve groundwater quality. 43% of the wells tested were less than 2, which is that background or natural levels. So somewhat similar to chloride in that aspect in regards to there is about half the county, which appears to be relatively uninfluenced by land use activities. If we look at the average concentration, it was about 4.2, and the maximum concentration we measured was 41.4, so almost 4 times what's considered suitable for drinking. When it comes to improving water quality or reducing our exposure to nitrate, it's important to point out that this is a drinking water issue. We aren't concerned about people using that water for bathing or washing dishes, but for drinking water, we definitely want people to reduce their exposure to elevated nitrate. So what are the solutions? Ideally, the long-term solution would be to eliminate those contamination sources or reduce nitrogen inputs. That's not always feasible because we might not control the land area that's responsible for your individual well water quality. So in the short term, oftentimes people are left kind of searching for their own solutions, unfortunately. And those solutions might be looking at the well construction or the well depth, particularly if the well is really old and starting to deteriorate. Maybe looking at a new well might be an appropriate solution. However, if your well is fairly recent, you probably don't want to take the chance of drilling a new well and finding out that you're dealing with the same problem or maybe a different water quality complaint or concern. So oftentimes people look at water treatment devices such as reverse osmosis, distillation, or anion exchange to try and reduce nitrate levels in their drinking water. Those would really be the only treatment options if you were trying to reduce nitrate in your drinking water. When we look at both nitrate and chloride, I mentioned that they're related to land use impacts. So moving forward in the future, one thing that we will do is try to look at developing statistical models that help correlate the water results for nitrate and chloride to some of the land use maps, as well as the soils and the geology, that will allow us to better predict what a nitrate level might be in somebody's well who didn't participate in this study. So the information we're collecting here really, is limited in terms of how many people we can reach immediately through water testing, but the information will be used to create better models that will serve all Sauk County residents. But I just show this to kind of highlight some of the things that we're hoping to do and highlight some of the things that might be coming next for the project. Lastly is conductivity. Conductivity, again, it's an overall water quality test that measures all ions. So it includes nitrate and chloride and hardness and alkalinity. So again, it really is the combination of both land use and geology and soils that go into the numbers or the results that you receive for conductivity. This one is going to be really interesting for me, I think, when it comes to understanding what role weather variability might play in water quality. Because conductivity is a relatively inexpensive test. Conductivity is something that a lot of people could actually monitor at home relatively inexpensively with a conductivity meter. So if we can learn kind of about conductivity and how it relates to the other tests, this might be a test that would have more wide implication for homeowners to be able to more effectively monitor their water quality on a continual basis and not have to necessarily submit a sample to a lab in the future. So this is really laying the groundwork for more kind of future technology advancements that will allow people to better understand fluctuations in water quality. So that's an overview about the testing, maybe a little bit of a preview into the results and what we learned. I just want to kind of highlight where we hope to go from here in terms of the testing that you will all be involved in, and then what's coming in year 2 regarding the data and analysis. So for the test kits for year 2, we were a little bit late in sending them out this year. So in order to get a little bit back on schedule, we are hoping to mail kits out sometime in November with the goal that people can collect those samples and mail them back by probably December 1 to kind of beat the Christmas rush, if you will, of the post office. We're hoping to do it in a way this year that allows you to receive the package at home and also put it in your mailbox and get picked up by the postal carrier. We want to do that, one, for convenience, but also because we don't know where we're going to be with regards to COVID-19 and any restrictions or health issues that people have. We definitely don't want people to be put at risk. So we're investigating ways to make it even more convenient in future years than it was last year. When it comes to the data side of things, what we'll be working on in years 2 through 5 is how to investigate the relationships of water quality results to the complicated land use, soils, geology, well construction variability around the county. Again, our hope is to develop statistical models that could better predict water quality risk for wells that weren't a part of this program. We also want to start integrating that temporal component to our data analysis. So with 1 year, it's really difficult to make any inference or guess as to how the water quality is changing. But by testing every year for 5 years, that's really our goal to see, are there certain wells where there's a clear increasing or decreasing trend? If there's not a clear trend, but wells fluctuate, what does that tell us about water quality results and what could be expected for typical fluctuations from year to year? And then lastly, we've talked about it a few times now, how does weather impact water quality? Those are all things that will only come from years 2 through 5. And then lastly, I want to highlight that we are working on a website for being able to more effectively communicate this information. And I'm going to quickly share kind of what that website looks like, but you'll see that information here. And one thing I'd point out is that when you click on an individual well, you'll see it's very vague. We never want to be able to identify or have people identify that a well water quality result came from a specific or an individual parcel. So any of the maps that we provide are going to be very generic. They're going to be very, at a high level or a very ambiguous scale, so as not to reveal that water quality came from somebody's specific property. But you can see there's a well ID that we will be providing to people in future communications. So when you click on the map, you will know your individual well ID, but none of the other participants will know that that's your well ID, and certainly the general public will not know that that's your well ID. That's a generic well ID that we assigned for this program. Other functionality, though, is that it will aggregate the information by town. So I kind of highlighted the county-wide results, but you would be able to see kind of what is the average, minimum, and maximum for your specific town. And in this case, we're showing the results for nitrate, but that functionality, that ability would be there for any of the water tests that were indicated or performed in this program. So there's the maps. There's also tabs here that tell us or provide a little bit more information about the project. If people have questions about the tests, all of these tabs here would provide some of that background information we went over in this presentation. And then again, when it comes to exploring project data, you have the maps, but we'll also be adding functionality that will allow you to look at other summaries or ways to view that information as well. And the things that we'll be able to do with regards to mining this data only get better and only get more exciting as we move forward in the project. I wanted to highlight that just so that you know that if you have questions about the data or the results, or you couldn't see the maps, that there will be opportunities moving forward to do that. I'm going to go back to the presentation for one more slide, which is the last slide. And it's basically thanking all of the people that helped or sponsored this program, but also providing my contact information. We obviously have some time now for question and answer, but if there are questions that either you don't feel comfortable asking on the program today, or maybe you think about
Hey, Kevin, you got muted. Can you unmute yourself?
I just unmuted. I don't know. Sorry about that. But basically, here's my contact information. If people have follow-up questions that we don't get to today, feel free to either call me at the phone number provided or email me, and I will do my best to respond to people's concerns.
Awesome. Well, thank you so much, Kevin, for sharing all this information. And I know folks will have some questions. You should be able to unmute yourself if you have a question, or if you need help with that, let me know. But you are able to unmute, and I don't know if folks have any questions they'd like to start with. You should be able to unmute yourself. John, can you unmute yourself? Okay.
Yes.
Awesome. Okay, great. I just want to make sure that I don't have everybody still muted and they can't unmute. So are there any questions for Kevin or about the program or next steps or where we're going from here or anything like that?
You want to ask a question?
I'd like to ask Kevin a question, Harvey Reader. Question is, what about your testing of artesian wells? Do you have any of those in your portfolio?
The question, and you can correct me if I don't articulate it well, but it's about artesian wells and whether we have any artesian wells in our study.
Yeah.
We didn't. We might. I guess I don't know for sure. If we do have any artesian wells, it would be residential private wells that happen to have artesian properties. I know there are artesian wells that people might go to at roadsides or maybe public parks where they fill up their water jugs. We did not test any of those. Just highlighting real quickly though, artesian wells are wells that tap into a pressurized aquifer, which means that water flows out of the ground or is pushed out of the ground without the aid of a pump. So there's oftentimes nothing necessarily magical or special about that water. It just means it's coming from some sort of pressurized aquifer system, which hopefully or sometimes might be due to some sort of confining layer that might limit the amount of kind of surface activities that get into that water supply. But that's not always the case. So to your point, it would be good to test artesian wells. We did not do that for this project, but that's not to say that might not be something we look at doing in the future if they're publicly accessible artesian wells. Certainly if it's a private well, that makes it a little bit more difficult. But in the future, that might be something that the county wants to consider is maybe looking at testing those.
Well, I have property up by Lake Redstone on a highway that I built up there many years ago. And there now I'm considering doing building some cabin or something, a house or whatever there. And that area where I'm at, I've been told strongly by others that there's artesian systems there. And I'm hoping that I'd be able to use an artesian system in my place. Although when I built the road up there, County Highway F, we ran into a lot of artesian activity. And I had to build and design courses for across, like French drains across the highways in order to allow for that interception of water to be in a flowing condition to an area where it gets drainage. But anyway, my area is close to some of these areas, and I just was wondering about that aspect of it, and I'd be open to letting you test that frequently or whatever.
Sure, that'd be something we could definitely follow up on. Artesian wells. I think a lot of times you're going to be more likely to find artesian wells on areas lower on the landscape or lower in elevation.
Yeah.
And the other thing is that oftentimes the flow out of those will correspond to precipitation patterns. So maybe areas or time periods of the year like spring where you have more recharge, those are flowing at higher rates. Or years where you have a lot higher rainfall, they might be flowing much greater. And there might be times where wells lose their artesian properties because the water table goes down. But artesian wells are fascinating, and they certainly are important to test because there's no guarantee it's going to be good quality water.
Right.
Hey, Kevin, I have a question here in the chat. It says, would it be possible to obtain a second kit so we can test at the pressure tank and then at the tap so we can effectively see what our in-place systems are doing for us?
not through this project, just because of limited funding. We're really hoping to get at the raw water. But certainly if people have a water treatment, either water softeners or reverse osmosis systems, the extension department at Sauk County does have testing kits available where you could test that treatment system for a fee. We were asked in the presentation last night in Greene County if we're still accepting participants, and we unfortunately have to say no in terms of adding tests at this point. Our focus from here on out really is to try and sample as many of the same wells as possible for the next 5 years. And just due to funding, we kind of have to limit it to those wells those 394 wells that we tested this year. So there are opportunities, unfortunately not probably through this program, to do a pre and post treatment sample.
So you can pick up a homeowner test in our office, which is on the 3rd floor of the West Square building in Baraboo. We're open every day. And if you don't want to come in, I think there's ways we can get it to you. I have another question in here. Kevin, it says, do you have contact or email address for the Wisconsin Department of Safety and Professional Services for recommendations for reverse osmosis, distillation, or anion exchange?
Navigating staff directories for state agencies can be challenging. What I can say is, and nobody that works for DSPS will necessarily provide a recommendation, but what they do have is a list of devices that have been approved for installation in Wisconsin, and that approval process basically certifies that the device will work. And really that is something that's available online. If you're looking for that list or you're having trouble accessing that list, I would be able to help you obtain that information, because I know it's there, and I wish it were easier to find, but it might be frustrating if you've never had to access that before. But that would be what's out there. Unfortunately, working for the state, we have to be, I shouldn't say unfortunately, fortunately, we have to remain unbiased, which means that the information you're getting isn't swayed one way or another. So we don't provide recommendations, but we certainly can provide you with a list of those devices that have been approved for installation. We would recommend using one of those devices, especially for health-related contaminants.
Are there any other questions from the folks that are online?
Yeah, my name is Ron Tatel, and some of our neighbors have radon. Can that appear in your water in some way?
Sorry about the phone here. I heard your question around. Sorry about that. So the question was about radon, and radon we are mostly concerned about for indoor air. We know it's an inhalation risk, and that's the primary concern. It's generally a problem for the lungs. So even if we do find radon in water, it's generally not something we encourage or require people to test for in their drinking water, because the risk in drinking water is quite small. We definitely want people to evaluate their indoor radon, especially in basements or in winter time when our windows are sealed up. But most cases, radon in drinking water is not something that we find to be a problem, and therefore it's not a test that we often recommend for folks. And there are tests out there if you are concerned, but we feel that the risks of radon in drinking water are quite small.
I'll just mention that you can get a radon kit for air quality at our Sauk County Environmental environmental health department, which is part of public health, also on the 3rd floor of the West Square building. So I know you can pick up a radon kit for, like I said, indoor air quality there. Any other questions before we wrap up tonight? Kevin, can you stop sharing for a second? I want to just put up the website one more time. And I will, oops, mention it right here. Oops. So I just wanted to one last time, can everyone see the for more information slide? Am I sharing? Oops. Let me do this. I'll put it up here. Okay. Current slide. So I just wanted to show this link one more time. And so the website for additional information, including the PowerPoint tonight, which I'll put on tomorrow, a recording of this, the website that Kevin referred to, we will be putting on this website. So it's sauk.extension.wisc.edu. So I want to make sure everyone got that. With that, I think we are wrapped up. So thank you so much for joining us tonight. I really appreciate it. Feel free to reach out if you have any questions. Otherwise, I'd say look for the testing kit for year number 2 in November. All right. Thanks, everybody.
Thank you.
Thank you.
Thank you.